Okay, the time's come for us to look at this from a theoretical perspective. So if I were to draw my devices in, we have leaf 101 and leaf 102 in the configuration. We have leaf 201 and, I'm sorry, spine 201 and spine 202 in the configuration, and they're connected following the values or the configurations for a Kloss architecture. I think my pen's out of ink, so I'll just go ahead and use another one. So I have my host. So here I have host 1 and here I have host 2, and we saw that those were indeed connected. But what we want to do right now is we want to talk about what's happening in the environment when we look at this from the perspective of the Anycast RP. So remember, we came in here and we configured the Anycast RP address. We used two loopbacks. We used loopback 200 that had the same IP address. And then what we did is we also configured another loopback, 201 and 202, and they had unique addresses. So these were the same address, and these were unique. Now, what we've done so far is we've gone in and we've shut down the NVE interfaces. So the NVE interface 1 is actually down on both sides. Now what I want to do is I want to bring one of them up. What we're going to do is we're actually going to come in here for NVE1, and what we're going to do is we're going to bring this interface up. But I want to add the caveat of what it is we're going to be doing, because what I want to do is I actually want to do a sniffer. So what I'm going to do is I'm going to open up a session of Wireshark to each of these resources. So on these interfaces, the one pointing towards Ethernet to leaf 101 on spine 201 and to leaf 101 on spine 202, what I want to do is I actually want to use Wireshark. And specifically, I want to look initially at PIM traffic. Because what we're going to find is that when we bring the NVE up, the NVE is going to need to speak to my rendezvous point. And remember, we have two devices that can actually serve as the rendezvous point. So what's going to end up happening is the NVE from its LO100 unnumbered interface is actually going to send a PIM join message. That PIM join message is actually going to be coming from the source IP address, and it's going to be going to 224.0.0.13. Now, in order to be able to do this, I want to stage the lab and I want to get everything set up. So the first thing I'm going to do is I'm going to log into my EVE-NG session, and what I'm going to do is I'm going to open up a Wireshark session off of each of these spines, and it's going to be looking at traffic as it comes in. So what we'll do is we'll actually go ahead and dive into that from the perspective of my resources. So we see here that I am interested in traffic. I'm going to bring up NVE1 on 9K1 or leaf 101. And what I'm going to do is I'm just going to come over here and I'm going to right click and say I want to do capture on port Ethernet 1.1, and that's going to be pointing towards leaf 101. Let's see if this opens up for me. And it does. And then what I'm going to do is I'm going to do the same thing for port 1.2 on leaf 202. Ethernet 1.2. Let's see if this session opens up. And we should have both of these guys function. So I'm just waiting for 1.2. All right, now we see I'm seeing packets. I'm seeing IP OSPF configuration, hello messages going back and forth, hello packet, hello packet. We can see here I'm seeing CDP, VTP, DTP, PAGP, UDP, all of that stuff, UDLD actually. And what I'm going to do is I want to filter these. I want to look specifically for protocol independent multicast traffic. Now we're going to see protocol independent multicast traffic. Should be coming in the form of our joins, and you'll notice that it's going to the address of 224.0.0.13. That is the PIM v2 address. Now this isn't sending any refresh, so let's go ahead. Sometimes this just kind of freezes, so I want to make certain that that's indeed not the case. And I just want to see something come through here. I should see an OSPF packet come through here at some point, just to see if it's working. So I'm going to refresh this one, say continue without saving. Let's see if I can get some output from it just on its own. Not seeing anything as of yet. So what I'm going to do is I'm going to close this, and I'm going to open up another session, Ethernet 1, 2. Like I said, I just want to be careful that I don't have a dead Wireshark session. Okay, there we go. So we're receiving the hello packets. So what I'm going to do is I'm going to go ahead and change this to PIM, Protocol Independent Multicast. And now that that's done, all I'm going to do is I'm going to go to 9K1, and what I'm going to do is I'm going to no shut its interface, the NVE. So where am I? I'm under the NVE1. It says NVE, so I'll just say no shut. And then what I'm going to do is I'll just minimize or open this up, and what we should see here is if we take a look at what's going on, we notice that we're seeing some things. Now remember, when we talked about multicast traffic, we talked about PIM registration, and we talked about the register stop message. You can see this is actually going through. Now one of the things that I want to pay attention to here is that I'm going to go to this switch right here, 9K4, which is going to be spine 202, and I want to look at some of these joins. So I see here I've got a join coming from 183.1.202.202. Notice I've got one coming from 183.101.101. Let's look at that one. So if I look at, I'm going to drag this part down so I can see into this configuration. And what we're going to see here is you'll notice that this is coming from 183.1.101.101, and it's destined to 224.0.0.13. And I'm going to look at the PIM configuration in here, and did I click on the right one? No, I didn't. I clicked on one down, one up. All right, so we have PIM, Protocol Independent Multicast. This is a join. I want to look at the PIM options that we currently have. Now, notice it says I am sending upstream neighbor 183.1.202.202, and it is going to be for 139.999. If I take a look at the group configuration, this is not the one that I'm looking for. I'm trying to find what is referred to as our join. So 183.1.1.1, here it is right here. So let's take a look at this one. So if I look at what's going on here, you'll notice I see something. I see a source of 183.1.202.202 going through. Actually, no, this is not the right one. Should be coming from 101, since it's the one that I brought up. What I'm trying to find is I'm trying to find the address that I am using to join. Here it is. So if we pay attention to what I have here, so this is coming from 183.1.101.101. Now that's the IP address of 9K1 or Leaf 101, and it's sending traffic to 224.0.0.13. Now what it's doing is it's actually sending a PIM join. So it's sending it to 183.1.202.202. The group that we're joining is 239.9.9.9, and it is destined to the 10.1.200.200/32, and we can see our bit configurations here. The S stands for sparse mode. The W stands for wildcard. And we see in the configuration R stands for rendezvous point. And we can see it's actually coming from 10.1.100.101. Now that is the loopback of the interface that is being used by the NVE. So just to illustrate that point, if I go back over to 9K1 and I say show run interface LO100, we see that that's that address. So what we just saw in the output here is the join where this device has tried to access the rendezvous point. Now what I want to do is I want to look at this from the perspective of our light board. So looking at what's going on right now, we see that I actually came in and I turned on NVE1 on Leaf 101. And what ended up happening is it actually sent a message to 201, the spine, which is acting as a rendezvous point. Remember, they're both rendezvous points. So they're RPs. Let me grab my eraser here. So these are both RPs. So it sent a PIM join. Now that PIM join is interesting because it allows this device to join the actual multicast fabric. So I can actually register with that multicast address of 239999. It's also important to note that once that actually happens, the NVE, so on Leaf 101, it is actually going to send a message called the PIM register message. So it's trying to join the fabric. And you'll notice it's actually going to go, in most cases, in this specific case, it should go to the other rendezvous point. Because this PIM register is actually a unicast. So the multicast is going to be re-encapsulated in unicast and sent directly to another switch. Now remember, we talked about the benefit of equal cost multipathing. Now, since this join message that we saw actually went to Leaf 201 in our case, what's happening here is that this is a different flow. Remember we talked about the 5-tuple? The 5-tuple, so my source IP, my destination IP, my source port, my destination port, and my protocol, which is going to be 224.0.0.13, constitutes one flow. And it chose to actually send that traffic down this link towards the rendezvous point of spine 201. Then it sent the PIM register, but the PIM register is actually going to be going to 10.1.200.202, and it's going to have a different 5-tuple as a direct result of that. So the 5 tuples are different. Therefore, I'm going to send it across another link. So when it comes to that PIM registration message, that PIM registration message is going to go down towards spine 202. It's also important to note that spine 202 will be responsible for sending the subsequent register stop message. So we have the PIM register, the register stop message. And what I want to do is I want to take a look at that from the perspective of the Wiresharks, and we'll do that in the next video. I'll see you guys there.